I thought so. I think so.
I I think so too. I mean, the little, what did they call it? It's not an applet. Well, kind of an applet, I guess.
I think it was. I don't know.
Let's see.
Sample.
Yeah.
Oh shoot, I didn't want to do that.
So do you just type
I
in
thought
like
so. I think so.
I I think so too. I mean, the little, what did they call it? Oops, sorry.
so? But I mean, I'm not sure how you would use it because you're supposed to change the standard deviation or something.
Mm-hmm.
Do you just click on the bottom? No, like I don't even know how you change that.
I'm trying to see what I did. I did this Saturday. Hold on. For number 8.
Yeah.
Yeah.
Are you talking about part D?
Part A even.
What is the shape of the distribution of the sample means for each of the samples? What did I do? The scores normally distributed. Oh, because it said the scores of the GMAT are normally distributed,
Mm-hmm.
the shape of the distribution I put would be normal.
Right.
Like a normal bell-shaped curve.
Yeah.
How do you know that the distribution of the sample mean has this shape? Would you just say?
Well, isn't that like one of the rules?
Yeah. It was not the central limit theorem. Or no, was it the central limit theorem?
I think it is. Isn't that it?
Yeah.
Central limit theorem, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large.
Yeah.
And the sample size is 10?
So the rule that I think it was is if the parent population is normal, then the sampling distribution of X will always be normally distributed.
Right.
How many
that's
observations are. Do you see that?
Wait, hold on. Wait, say that one more time.
So under 3.1 on the little reading we had to do, it says if the parent population is normal, then the sampling distribution of X will always be normally distributed.
And the parent population is normal.
Uh-huh.
Mm-hmm.
Okay, I think that's not the central limit theorem, though.
No.
Well,
it's
well, it's underneath it.
yeah.
Because I think the central limit theorem is just if the sample mean will be approximately normal if the sample size is large.
How many observations are required?
Yeah, I mean, but that's underneath the, are you looking at the summary on the bottom where it says central limit theory?
Wait, are you in the textbook right now?
Yeah.
Let me check.
Like 3.13.
Yeah, there's like section 3, central limit theorem, and then it's 3.1. And it's got all those rules for it.
Yeah.
So I think
those are all rules from that?
Yeah.
Oh, okay. Then yeah.
Okay, where's Irvin?
Okay, gotcha.
So it should also be normal then.
Yeah. Let's try them again. Not delivered. Why? I don't want to start without him. Maybe his phone's being weird. Or maybe my phone's being weird. Did you get that text that I sent, Miranda?
I did, yeah.
Okay. Huh. Well, I mean, what do you guys think? Should we start and see if he joins in, and then we can catch him up, or?
Yeah, minutes in. I don't know where he's at.
Huh?
I don't know. We're almost 15 minutes in. Do you think he would have texted us by now or something? Or
Yeah, that's my thinking. 'Cause he said 9 will work.
yeah.
I don't know. I just texted him again and asked if he got the invite to it. So,
Yeah.
I don't know. Maybe we start and then
Yeah.
we can.
If he couldn't be too much later than this, could he?
It's about 15 minutes late, so
Yeah. So hopefully he's coming in any second now.
yeah. Okay. Well, what do you think, Kaylee? Should we start?
I think if we start, he could probably jump in, and I think he would still get points.
Yeah.
Yeah, we're not too far in yet.
Okay. Let's do it. 'Cause I'm ready for bed.
Yeah.
Okay.
Just have your husband shake you every hour or so.
Make sure I'm alive.
Yes.
He said, "Oh, you guys were talking about tonight." Yeah.
Oh no, was he confused?
Oh yeah, I thought we were gonna meet tomorrow. You guys go on ahead. I'm not home right now. Oh no.
Oh. Darn it.
Well,
I just texted him to make sure he's sure that that's okay with him. I mean, you can't lose too much points for not being in the video, I would imagine.
Yeah.
I mean, if you
It's
guys
just
want,
not-
you guys can meet again tomorrow. I mean, I just can't do it tomorrow.
Tomorrow's not good for me either.
Yeah. Okay.
I don't know.
Let's see.
It's just one. He couldn't be.
Yeah.
Couldn't be
you
too
can't
much
miss
fun.
any.
I mean.
Okay, he said yeah. Go on.
Okay.
Okay. So, let's see. Number 3. Are you guys ready? I guess.
Oh, wait, hold on. I'm getting there. Group meeting. Okay, clicking start. Okay. Okay. Ready.
It looks like the homework, so that's good.
Oh, good.
Okay, when taking samples of n when n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? So the sample size is low. Doesn't that mean that it will also be right skewed?
Yes, because it can't be normal when there's such a low sample size.
Right. That's right.
And if you use that applet, the mean is skewed right. Okay. Do you want to do the next one, Miranda?
Sure. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is right skewed? Is 100 still small?
It's big. That's big, because it's bigger than 30.
Yeah.
So then,
So that
norm.
would be normal. Yeah.
Okay.
When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? Still be normal.
Yeah. Hold on one second. Okay. When would the distribution of means be normally distributed? Data are drawn from a population that is normally distributed and the sample size is small. That would be correct.
yes.
Yeah.
Data are drawn from a population that is normally distributed and the sample size is large. That's also.
Yep.
And then data are drawn. This data are drawn. That doesn't sound right. Data are drawn from a population that is right skewed and the sample size is small. That one's not.
No.
And then data are drawn from a population that is right skewed and the sample size is large. So it should just be all of them except for that one, right?
Yeah, except for the one in the bottom, the second
middle.
to the bottom.
Right. Yeah.
Yes.
Yeah.
Okay. Ready?
Yep.
Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean x will follow a normal distribution. We only pick one here, right? For bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean. About 90% of the data will be within two standard deviations. And approximately 99.7% will be within 3 standard deviations.
That's a no.
If the sample size is large, the sample mean x will be close to the population mean of mu. If the sample size is large, the shape of the sampling distribution of the sample mean x will be approximately normal.
Would it be the last one?
No, because is that the one about the large, though? Is that
So this is the actual definition. The study. You observed in these simulations that if the sample size is large, the random variable x will be approximately normally distributed. In other words, the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large. This important result is called the central limit theorem.
So it would be the last one.
Yeah.
Because that pretty much was exactly what you said.
Yeah. Which is, if the sample size is large, the shape of the sampling will be approximately normal, right?
Yeah.
Yes.
Okay. Perfect. Let x be a random variable with population mean of 10 and the population standard deviation of 6. Suppose a sample of the size 36 is drawn from this population. What is the mean of the distribution of the sample means?
Hold on.
Isn't it 10?
What is the mean of the distribution of sample means? Oh, gosh.
Of the sample means, what is this? Oh, what is this mean of this distribution?
Mean and standard deviation of distribution, it says, these facts hold for the sample mean x of any simple random sampling size n drawn from a population with the mean and standard deviation. The mean of the sample mean is the mean. And then the standard deviation of the sample means is the standard deviation divided by the square root of the number of samples.
So if the mean of the sample mean is the mean, then it would be 10, right?
I think so.
Oh gosh, okay.
Okay, and then this one we have to actually do a calculation. So it would be 10 over, standard deviation. So 6 over the square root of 36 to find the standard deviation.
Is that 1?
Yes!
Square root of 36. Yeah, I got 1.
So how would we do 3 decimal places?
What? What is the wait, I think we did something wrong, because remember, if we do standard deviations and we get 1.
Standard deviation of the sample means is O, or the standard deviation, divided by the square root of n.
Square root of 36 is 6, so 6 divided by 6 is... So it would just be 1?
I guess.
With 3 decimal places?
Yeah. 1.000?
Oh my goodness, I have no idea. Seems sketchy, but I don't know any better. This one was like a little bit confusing for me. I don't know why.
They use the word means too often.
Yeah.
Everything was a mean of means, and you're like, what the heck?
Yeah, it's like, okay, well, I'll just read the next one, and maybe we can come back to 9.
Okay.
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 Regardless of the distribution of the population, if the sample size is large, bigger than 30, what would be the shape distribution of the distribution of the sample mean? It'd be normal,
Yeah.
right? Yeah.
Yeah.
And that's, oh, is that the large number rule?
Think
Or
so.
Hold on. Let's double check.
the
Yeah.
law of large numbers states that if the sample size is large, then the sample mean will typically be close to the population.
Population mean.
So that's-
And the
Central limit states that if the sample size is large, that x will be approximately normal. So that's central limit theory.
Yeah, that would be central limit.
So this is large, or
It's the central limit theory, because the law of large numbers is mostly dealing with sample mean close to
yeah.
the population mean.
Okay, yeah, that was something else.
So that reaffirms question 8. Because of the law of large numbers, since the sample size was greater than 30, the mean should be the same mean as the population mean.
Okay.
Know what I mean? Huh?
Ha, ha.
Okay. So, that was so stupid. Number 9.
That was a good one.
I mean, with number 9, there really isn't anything we could mess up because it's just the O divided.
Right.
It's a formula, so I don't know. Maybe we put 1.000 and
And hope it's right.
yeah.
Okay, well, let's do it.
All right.
Oh yeah, that's right.
Yay!
Man, we're so good.
Good.
Awesome.
Awesome.
Okay, you guys get some sleep.
Yes.
Oh, I will.
Okay.
All right. Thanks,
I'll go ahead
guys.
and post, and then we'll figure out whether we want to do Wednesday or Thursday. So,
Okay.
okay, see you ladies.
Okay, bye.